All right, so 7 o'clock. It is the last live of the term. I'm going to be going over compound interest because that's one of the applications of exponential equations that we are learning this week. Plus, it's just something very handy to know and understand for your own life. So that's what I'm doing. So we'll get started. So compound interest is when you earn interest on top of interest. So it's basically if you invest money, your interest gets put into the account, and then you're also, you're not doing anything. You're not removing more money or anything, and you're not putting in more money. You're just letting it sit there, and then you get interest the next month, and so it's interest on the original plus the interest that you earned. And so you just keep earning interest on top of what your previous interest was. This also occurs on credit cards if you don't pay your entire balance off, because if you don't pay the whole balance, you'll get an interest fee. And then if you don't pay off again, you may have an interest fee and then charge an interest fee on top of that interest fee because that's now your existing balance. But most of the time, the situations that we use compound interest are the savings accounts where you just plug in money and then you let it sit. So basically, we actually, this formula came up in the review chapter when we were just talking about exponents and like plugging in numbers, but now we're going to be doing more complicated stuff with it. But essentially, and I'm going to highlight the formula here for compound interest. Whoops, that is not the highlighter. This is the highlighter. So if you're investing P dollars, and we use P because that's usually called the principal, like when you're having a loan, they refer to it as the principal of the loan. So P dollars in an account that earns an annual compound interest. So we're always doing things in terms of annual interest rates, So R is your annual interest rate, which is usually given as APR and credit cards and things like that. So I believe that I actually never looked up what that stands for. It's probably annual percentage rate, I think, is what APR stands for, but that's the percent that you get over the year. But that's actually a different percent than you get monthly or however you're, when you're getting interest. But the specific formula, if you're getting annual interest, is A equals P times 1 plus R to the T. And that tells you how much money is in your account T years later, and it includes the interest. So it's not giving you just the interest, it's giving you the amount you invested plus the interest. So that's the compound interest formula that we talked about in the review, like way back in week 1. We're just looking at like exponents and plugging numbers in. If I can get this slide to move. So there's actually variation on the compound interest where the compound interest formula for annual means that you're getting interest only once a year. And that's not actually how the world works. We usually get interest multiple times a year. So there's a modification to the formula where it's right here. You have to take your annual interest rate and divide it by the number of times you're getting interest. So if you're getting interest monthly, which happens with most savings accounts or a CD, then you're going to divide it by 12. So if your interest rate is 3%, you would divide that 3% by 12. And if I grab a calculator, because I don't know what 3 divided by 12 is, that's 0.25% each month. So when you see advertised an APR of 3%, that's not 3% every month usually. It's a smaller amount because they usually give it an APR. So it's actually a lot smaller if you look at it on a monthly rate than it is for the year. So it's a little misleading, but you need to understand how that works. So we have to modify the formula so that we're dividing by the number of times a year you're getting that interest. And then you also have to multiply your years by the number of times you're getting interest. So that's why it's NT and as the exponent. So quarterly is 4 times a year, monthly 12 times a year, and daily, even though there are some months that are, or some years that are 366, we use 365 generally in the formula. And so then we also have a situation where there's compounded continuously, which means like every second or every little, nanosecond or whatever, trying to do it as much as possible. Basically, if you were taking interest to infinity, that's what's considered compound continuously. And so that is where we introduce E, which you guys learned about this week, Euler's number. And that formula is A equals PE to the RT. And that is not how the real world works, because we can't really use infinite interest. So the real world will just be regular compounding interest for some sort of n times a year, but there are compound continuously, if you did it every second or whatever. And a lot of people that go into stocks, that's kind of how they think about their math, is because like, oh, if I make this trade and then I do this, they're kind of looking at it as like really tiny increments, which is sort of what compound continuously does. So just as a note, all of these formulas are assuming that you're depositing money and then you're not putting in any more money, you're not taking out money, you're just letting it sit there. So usually the only type of situation where this will occur would be a certificate of deposit, or CD, because you get a penalty if you withdraw money and you can't add money once you open it up. So that's really where this formula is mostly used. If you take an accounting or finance class, then you learn about future value and all these other formulas that take into account the fact that you may add more money later on or take money out, and the more complicated situations. But we're just looking at the most basic, where you're putting money into something and then you're letting it sit there and you're not touching it ever again. So these are the two formulas I've highlighted. Those are the two formulas that we need, and you're going to want to make sure you have in your notes or something, so that you can use this. So I've only got 3 examples, but we're going to be doing a lot of calculations here. So I'm going to kind of show you how you can do this in Excel and how you can do it in Desmos to kind of save yourself some time for some of these calculations. So this example here, we have, suppose that $10,000 is invested at 4% interest for 5 years under the following compounding options. So we've got annual, quarterly, monthly, daily, and continuously. So complete the table, and then we're going to say, what do you notice? Like the result, how much the total money you get at the end, what is the pattern that we're going to notice? So just to fill in N here, annual means that N is 1 because you get it 1 time a year. Quarterly is 4 times a year. Monthly is 12. Daily 365, and then continuously doesn't really actually have an N in the formula, so I'm just going to write not applicable. So we'll do the first 2 by hand, and then I'll show you how you can use technology to find the other ones here. So let's start with annual. So our formula, actually, let me write the formula in white. It's A equals P times 1 plus R over N to the T. And before we even do annual, let's write down what information we've got. So we're saying that we're investing $10,000. So that is the principal. So that is going to be P. That's always how much you're investing. It says 4% interest, so we're assuming that's 4% annually. So R is equal to 4%. But in math, we always use the decimal form of the number. So you divide it by 100. So that would be 0.04. You move your decimal place 2 to the left to convert it to a percent. And then it says for 5 years, so we're going to be using T equals 5. So it's always good to write that down So that way you know what numbers you're dealing with. The most common error I see is people converting the percent to the decimal incorrectly. So percent, per means divide, cent means 100. So if you remember that percent means divide by 100, then that's what you can do in your calculator to get the decimal form. So now let's start with the annual. So we've got A equals, we plug in for P, so that is 10,000 times 1 plus, and then we use a decimal form for R, 0.04. N is equal to 1 for annual, so it's just divided by 1. And then, oops, I've forgotten my formula, the N. That's N times T. So N is 1, and then T is 5. So we've got this expression, and we're going to follow the order of operations here. So first is the exponent stuff. So we've got 1 times 5, so we're going to have 5 as the exponent. And then inside the parentheses, because we can do this at the same time, 0.04 divided by 1 is just 0.04. We're adding 1 to that, so you get 1.04 to the 5. And that's the compound interest formula that you were introduced to in week 1. So order of operations means we need to take 1.04 to the 5th power first, and then multiply it by 10,000. So calculator is definitely needed for this. And I just always write down all the numbers that I see in my calculator. Don't round until the very end. If you round too early, then your answer could be, you could end up rounding multiple times, and then your answer is going to be off. And even if you did the problem right, Alex might mark it wrong because you've rounded too much. So it's just best to round at the very end. So I'm just going to write all of the decimal places that I see here. So I got 1.216652902. And then I'm going to multiply that by 10,000. I got 12166.52902. So we need to round this. We're dealing with money. Money always has 2 decimal places. So always round to 2 decimal places when you have money involved. So I'm going to write a vertical line after my 2 decimal places, and then you look at the number after the line. So it's a 9. If the number after the line is 5 or higher, you round up. So this 2 needs to be rounded up to 3. So when we write our final answer, we're going to get $12,166.53. And that's for if you get interest annually once a year. Are there any questions so far? Okay. You know what? I'm actually going to do continuously now because that's a different formula instead of doing the quarterly. I'll show you the quarterly on like Excel or something, but the steps would be the same. So let's do continuously. That formula is A equals P e to the RT. So there is no N in that formula at all. So I have A equals, and then P is still 10,000, E is Euler's number, so there's a button for that on your calculator. And then RT, so we have 0.04, and then T is 5. So we've got 10,000, and I need to multiply 0.04 times 5. That's 0.2. So I need to do e to the 0.2 first. And so I have a button on my calculator that says e to the x. Your button may look slightly different. It depends on your calculator and what you're using, but that's what mine says. And mine is actually in yellow. I have to hit the second button to get to it. But I'm going to do e to the 0.2. So that's $10,000. And then my decimals, 1.221402758. And now I'm going to multiply that number by 10,000. So I had 12,214.02758. So again, we're going to round to 2 decimal places because this is money. So after the 0.02, there's 7. So it's 7 means 5 or higher, means we round up. So that 2 is going to be rounded up to a 3. So for compounding continuously, we get $12,214.03. And you can see that that number is already higher than if you got interest once a year, because you're getting interest more often and it's getting interest on top of interest, so it grows faster. So you have more money there. So that's essentially, you know, it says, what do you notice? That's what you're going to see. You're going to see that the more times you have interest, the more money you're going to get. So I'm going to start with showing you how to do the quarterly, monthly, and daily in Excel, so you can see how you can use Excel to do formulas. So let me open up. I getting it Excel to work. Google Docs, the spreadsheets form of Google Docs will work as well for this. So I just have a blank Excel document here. And Excel has some built-in formulas for doing this kind of thing, but I'm going to show you how you can, I'm not going to show the built-in formulas. I'm going to show how you can use it using the formulas that we have to kind of demonstrate the algebra of it. So I can just set up a table just like we literally did. Annual, quarterly, monthly, daily. I'm going to, we could do, now let's skip continuously because that's a different formula. So N1 for, oops. 1, 4, 12, 365, and then result. So here's how you can, and actually we should make another table with our values. We've got P, R, and T. So P is 10,000, and if you want, you can put it in money format. R is 0.04, and then we're doing this for 5 years. So I can make a separate table with those values. So we're going to do the annual just so you can double check and you can see what we've got. So first, if you're writing an equation in Excel, you start with an equal sign to tell it you're writing an equation. That should be familiar because when we have equations in math, we have an equal sign. And then we're going to type everything to the right of our formula. And then the answer, what would be on the left, is actually going to display. That's how Excel formulas work. So we're going to just use sort of the formula because our formula starts with P. So instead of typing in the number, I'm going to click the cell. And this will allow me to change these values as needed, and it will just recalculate. So notice how it says H1. We're in the column H, we're in row 1, and this is a variable. So that way I can change whatever this number is, and it will automatically update because it's referring to it by its location and not the actual number. So that's why we're using variables here. It's very handy. Then to get a multiplication, you use the little asterisk here. And then parentheses. Our formula is 1 plus R. So I'm going to click where R is. And again, it converts it to a formula so that can change. Divided by N. Oh, I didn't make a thing for N. So it's going to yell at me right now. We'll just tell it to correct. I'll fix it. I forgot. I got to put, wait, no, I do have N in there. The N's right here. Let's go back to what I've got here. Divided by N. There we go. So you click your N for this one is annual. And then we need to get an exponent. So the exponent is the caret. It's the same shortcut you use in Alex. And some calculators have that button. So it's the caret symbol here. And then I have to put n times t in parentheses to make sure they're both in the exponent. So again, I'm going to click where n is, use an asterisk for multiplication, and then multiply by t here. And then I'm going to close parentheses. So I've got my p, and you can see it's color-coded. 1 plus r divided by n. And then to the exponent is n times t. And then if you hit enter, it gives you that number. And this is the same exact number that we got when we calculated this by hand. Now, the nice thing about Excel formulas is that you can copy the formula and it will recalculate it. So I could just click and drag and it will calculate for 4, for 12, and 365. But there's a little quirk about that because what it does is it shifts everything down. So if we don't want to change the P, the R, and the T and move these, when you put them into your formula, you use dollar signs. So you put a dollar sign before the letter and a dollar sign before the column, and then it will say, don't let that number change. We're not changing R, and we're not going to change T. But we are going to let n change because that's going to move as we go down. So what I do is I click. You see how the mouse changes to like a black plus sign from like the white plus sign? If you click and drag at that point and then drag down, it automatically then will compute the other numbers. And they're using the correct values. So you can even click and double check it's using your P, your R, your T, and then the value here. So we have just basically found the rest of the table here by using Excel. And so this can save you a lot of time, and this is just handy in your own life when you're really comparing things. So I actually do this when I'm like, you know, budgeting and I'm trying to decide like in my savings account, should I put money into this account with this interest rate or this one, or, you know, all that kind of stuff. I actually do these calculations. So these are the numbers. You see, we already got this one. And then we need to copy these numbers into here. So unfortunately, I can't have both open at the same time. So I'm going to just move this over and then copy it in. So we've got, oops. It got off the pen. $12,201.90. And then we have $12,209.97. And then $12,213.89. And so you can see the pattern. The more times you get interest, the more money you will have in the end. And that's the power of compound interest, is that the more times you leave it in there, the more interest you get, the more money you have in the end. Are there any questions on this example? Okay. I'm going to bring the Excel back here. So, you know, we filled this out by making this table. But if you want, you could do it separately, and you can put N here, and then you can put your answer here. So let's say maybe we did some weird thing and it was only 3 times a year instead of 4 times a year. So our N would be 3. So what I can do is I can still set up the same formula, P times parenthesis 1 plus, I click R divided by N. So unfortunately, it's kind of blocking where I would be selecting N here. So I have to read it. It's H4. I feel like I'm battleship. H4. So I'm going to just type H4 because it won't let me click it. There we go. And then I need to go into my exponent. It's N times T. So if we did it only 3 times a year, you can see it's less than the 4 times a year, more than the 1 time a year. But doing it this way, I can change this to 4. I can change this to 5. I can change the years, say 10 years. You can see how that it changes it. We can do a 2% interest rate. We can change this to $20,000. But the advantage of setting it up here and then using variables is that you can put your formula into Excel and then you can change it up and then it will calculate it for you. So that's one of the reasons why we learn algebra to begin with, is so that you know how to work with variables, so that, you know, in real life, if you're needing to do some sort of budgeting with interest or whatever, you can use Excel to make that easier, and you can do like what if situations. And this works, you know, I've done this for mortgages to try to figure out how much my mortgage is going to be, you know, how much interest am I going to pay on that mortgage. So it's really invaluable. So let's move on to our next example. Suppose that $20,000 in principal is invested for 10 years at a 3% interest rate with continuous compounding. So that continuous, that word continuous is really important because that's telling us that we need to use the formula with E. Determine the amount that the investment is worth at the end of a given time period. So continuous means we use the formula A equals P E to the RT. So we're given $20,000 in principal. We're given that it's invested at 10 years. We're given that our interest rate is 3%, which is 0.03. So we are given all of that information, and we are finding how much it's worth. So this is a good practice for you guys, because I did this example on the previous slide with continuous compounding. So I want you guys to calculate this out, and then you can type your answer into the box. I'm going to write the formula with the numbers plugged in. All you need to do is follow the order of operations, and then make sure that you can use your calculator correctly to get the right answer. Because if you can't use your calculator, if you're not sure how to use your calculator, that's going to cause some problems. So I will give you some time to work through this problem and see what you get. Okay, we've got one answer already. So I will let that answer sit there and I will start working through the problem so that you can see the steps while we let other people catch up. We'll see if other people get the same answer. So when I go through, I get, let's see, Ryan got 26,997.18. I get 26,997.17. And then because it's the number after my line is 5 or higher, we're going to round up. And so, yes, I also get 26,997.18. So I had to do 0.03 times 10 first. Then I did e to the 0.3. Then I multiplied that by $20,000. So I want to pull up Desmos this time to show you how you use Desmos to calculate this out. So I've got the scientific calculator on Desmos. So if you drop down math tools, we got scientific calculator right here. So this is what, if you don't need a graph, you're going to do this. So we can put this all in at the same time exactly as we see it, provided that you've got your stuff with the exponents in the correct spots. So it's PE to the RT. So we start with $20,000. And then to find E, you need to go to func over here, which stands for function. And then we've got this E to the X button. So I'm going to click that button. And now I'm in the exponent. You can see it kind of shifted, and now I'm in the exponent. So I have 0.03, which is R. And then I hit times. See how I'm kind of out? I think it moved me out of the exponent when I did that. So I want to be back in the exponent. When I hit times, it kind of gets me out. So you need to use parentheses. Because if you try to hit times, it will assume you're trying to go out of the exponent. We're not. We want to stay in the exponent. So use parentheses there. And so all you need to do then is plug it in here, and then you've got your final answer. And this is nice because if the interest rate changes, if you have a different problem, you can change that to 5, the answer changes. If instead of 10 years, it was 5 years, you can change that, your answer changes. If instead of $20,000, it's $10,000. So this is another way to kind of save yourself some time, because all you need to do is change the numbers here on the left, and then your new answer shows up. You do have to, make sure you're changing the correct numbers. You don't want to accidentally change the wrong number. And there's actually a round button too, which is really nice. So don't just put it anywhere. But I think if I put round here, and I think I've never tried the round button. There we go. So if you want to round it to 2 decimal places, you put round and then you surround your formula. So if I go back to the $20,000, we had 3% for 10 years, and then I'm telling it to round 2 decimal places, it automatically rounds it for you. So if you struggle with some of the rounding rules, you can use this button to round. You just do comma and then how many decimal places you want. So if I wanted 3 decimal places, I would just type a 3 there. If you want a whole number, you type in 0. So this is going to be also really handy when you're doing these kind of formulas and you're calculating these things out. Is if you have a calculator like this, and it's really nice on a computer because you could just highlight what you need to change and then change it, and then it'll recalculate for you. Are there any questions? Okay. So this is my last word problem example. And we're going to do, again, multiple things, but this time we've got simple interest and then compound continuously. And the reason why I'm doing compounded continuously is because I figured that might be the hardest with the E, so that's why I'm doing more of those. So Bethany needs to borrow $10,000. She can borrow the money at 5.5 simple interest for 4 years, or she can borrow at 5% with interest compounded continuously for 4 years. Which option results in less total interest? So this is like something you'd have to do. You really be comparing, because if you're trying to find a way, if you're trying to make the most money here, the best interest rate is not always the best, because it also depends, or the highest interest rate is not always the best because it also depends on the years and how it's compounded. So I'm gonna I gotta so you need to actually do the calculation, because sometimes you may have a higher interest rate, but if it's for less time, it doesn't actually make up the difference. And I've actually done this calculations with, I have a savings account, and then I was looking into opening a CD, and then I was like, well, I've got this much in the savings account, and I can get a CD for this length of time, but their interest rates are different. So which one is better? Should I keep my money for that same amount of time in my bank account, or should I do the CD? So this is a good situation where you really would be shopping around to find the best way to make the most out of your money. So to refresh, in week 1, we talked about simple interest, and the simple interest law is I equals P RT, and that gives you only the interest. Now, on the right here, we have compounded continuously, and we know that that formula is A equals P E to the RT, but that gives you the interest plus the amount you invested. So what we are going to, in order to get the amount of interest only, you subtract out the amount you've invested to get how much was just interest, because our final answer is the initial amount plus interest. So we need to now subtract out what we invested so we get only the interest, because the question says which option results in less total interest. So we're caring about only interest. So I just have to modify that slightly in order to get only interest. And now we're going to plug in our numbers. So going back to the problem, it says we're borrowing $10,000, so that's going to be P. And then we've got 2 interest rates. So we've got the simple interest rate, which is 5.5%. And when you convert this to a decimal, you divide by 100. So it's 0.055. And that's for 4 years. And then the other one is 5%, which is 0.05, also for 4 years. So we're going to be using 4 for both of these situations. What's different is going to be the interest rate and then their formula. So on the left, I'll start with the simple interest. So we have $10,000 times R, which we're using 0.055 for this one, and then T, which is 4. So we can just do that in one step on our calculator. Just literally type in all of that stuff multiplied together. And so we get $2,200 of interest from the simple interest. Now, compounded continuously, so it's, we modified our formula here. So I've got 10,000 E to, and now R is 0.05 times 4, and then minus $10,000. So I need to do the PERT part first before I subtract the $10,000 to get the total interest. So we've got 10,000 E to the 0.05 times 4. So that's 0.2 minus 10,000. And this is going to get kind of messy. So I'm going to, on my calculator, do E to the 0.2, and then I'm going to multiply it by 10,000 at the same time, just so that I can fit all of this here. Whoops. So I got 1, 2, 2, 1, 4.02758 minus 10,000. So then I just subtract 10,000, 2214.02752. And then because this is money, we're rounding to 2 decimal places. And because the number after my line is 5 or higher, we round up. And we get 2214.03 as the total amount of interest. So the question says, which option results in less total interest? And the simple interest gave you less interest. It has a higher interest rate, but because it doesn't have the power of compounding, it actually gives you less money than if you did the compounded at a lower interest rate. It's not a big difference here. It's like $14 difference, but it is a difference. And so this is really important just as a consumer to understand the difference of the different types of interest and to read the fine print on all of those things so that you know how they are generating interest. So that way you know what is actually the better deal to take. Because a lot of times they'll try to fool you. And if you read the fine print and you see how many times you're actually getting interest, or how they're calculating the interest, it may not be as good as a deal as it seems. So are there any questions? All right, so